Welcome to our discussion on dynamic panel data model, and if you recall, we were discussing a model wherein we are interested to estimate the determinants of firms employment from the UK context. We have 140 firms data, and the situation is dynamic in a sense. ith firm's employment in tth period depends on what the ith firm have already employed in the previous period. So, yt is a function of yit is a function of yit minus 1. So, basically this was the situation we were discussing. Dynamic panel data model, and our relationship is this: yit equals to yi t minus 1 plus beta 1 xit plus ai plus vit. And the presence of yit minus 1 basically introduces dynamism in the system. And in our previous class, basically we were discussing how to implement xt_2 command to estimate the system GMM. Before that, we have estimated a difference GMM using yit minus 2 as instrument for the difference equation. And when we said that lag of level performs poorly as an instrument for the difference variable, then we said that following Arellano and Boవర్ts 1995 and Blundell and Bonds 1998, we were estimating a system GMM also using the status that xt_2 command. And we said that differentiating system GMM from the difference GMM in terms of this command is very simple. In system GMM, we are removing the known level equation from the command. That means I need a level equation also. So, a level equation and the difference equation, both of them constitute a system of equation that we are going to estimate. And when we have a system of equation, then lag of level is used as instruments for the difference equation, and lag of difference variable, that means delta yit minus 2, is used as the instrument for the level equation, right. So, once again I will repeat that yit minus 2, this is IV for the difference equation, and delta yit minus 2 IV for the level equation, and the difference equation is written in this way: yit minus 1 equals to rho yit minus 1 minus yit minus 2 plus beta xit minus xit minus 1 plus vit minus vit minus 1. So, this is called level equation and this is called difference equation. So, when we have both level and difference equation to be considered as a system of equation, then what we are doing? We are using yit minus 2 as well as delta yit minus 2 as instrument. This for the difference equation and this for the level equation, so that our estimates the quality of our estimates improves drastically. And how do you measure the quality? While difference GMM cannot always guarantee that my estimates lie between the theoretically determined upper and lower bound, we have ensured that in a same model, system GMM can ensure that estimates are within the interval, that means within the upper and lower limit of the interval determined by OLS and FE, fixed effect. Then what we were discussing yesterday, that these estimates are quite sensitive towards the fact that what factor, what variable you are considering endogenous. So far, we assume that endogeneity is there only in YIT minus 1. That means, lag of the dependent variable is only endogenous and all other remaining variable are strictly exogenous. So, in our context, what we were discussing, that employment is a factor, is a function, YIT is employment, and that is basically a function of YIT minus 1, then wage, then capital, right. And we assume that endogeneity is there, this is endogenous, and these two are actually exogenous. Rather, we have another variable, industrial output also we can take. So, this is also exogenous. Now, if we assume that if labor and if wage and capital also becomes endogenous in this relationship, then if we model that, our estimates, they change drastically. And there are enough reasons to believe that wage and capital are also endogenous in this relationship, because as we all know, employment determines capital, and at the same time capital determines how many laborers you will employ. At the same time, how many laborers you employ, that also determine how much capital to be employed in a particular firm, right. At the same time, wage and employment, they also sometimes are determined simultaneously. While wage, we can say that it is a labor demand function and employment is basically a labor supply function. So, this labor demand and supply, they basically determine equilibrium wage and labor supply, that is coming from purely demand and supply of labor. So, if that is the case, we can model W and K also as endogenous variable along with YIT minus 1. And if we do so, then our estimates, they change drastically. And what we will do, we will we were discussing the sensitivity in the context of difference GMM, and what we will do today, we will once again discuss the sensitivity in the context of system GMM model also. So, that means we will re-estimate both difference and system GMM by modifying the specification. That means, which variable we will consider as endogenous and which variable we will consider as predetermined and exogenous. So, once again we will use the same data. This is the same data that we have been using, Arellano-Bond's original data set from 140 UK firms. So, to access the data, as I have already mentioned, web use AB data. So, first what we will do, we will first estimate the model considering only YIT minus 1 as endogenous variable. So, xt upon 2 and then in L1, in L2, and then we have W, then WL1 capital, then capital of lag 1, lag 2, then we have YS, YS L1, YS L2, then I have ER specific dummy. So, this is my first specification. So, since I have been writing this command so many times, by now you must be habituated with this command. After XT_2, I will put this line. So, this line basically specifies your econometric model, and next part of this command basically indicates which variable you are considering endogenous and which variable you are considering as exogenous, and that exogenous and endogenous variable are differentiated by GMM style and IV style instruments. So, what I will do now? Now, I will put my GMM style, and within that I will put only in L1. In L1, and then I have IV style, and in IV style I will put all those variables like W, L1. So, here I will put all the variables as exogenous. So, I will put W, and then I have K, then KL1, KL2, KL1, KL2, and then I have YS, YS1 and YS2, and then I have YR dummy, YR star, and then since this is a difference GMM, no level equation, and I need robust estimates, small sample correction. So, this is my model. So, I am considering only the YIT minus 1 as endogenous variable, and look at this. In this model I have 0.68 as the coefficient of NL1. So, coefficient of my lag dependent variable coming out to be 0.68, and as you know that 0.68 is basically not lying within the theoretically determined bound by FE and OLS estimates. It should lie between 0.73 to 1.04. So, system difference GMM, by considering only that factor, is not able to ensure my estimates lying within the interval, right. So, what we will do now? We will estimate the same model by considering the fact that my WL1 and KL1, they are also to be considered within the GMM style instrument. That means, wedge and capital also are considered as endogenous now. What happens in that situation? So, we will put xt bond 2 and then N and then NL1, NL2, okay, WL1, WL1 and then capital then KL1, KL2 and then we have output YS, YSL1, YSL2 and then we have YR star. This is the specification and then GMM style. Within GMM style, what we have NL1, then I have WL1, then KL1. So, these are also now included in the GMM style. And then in IB style, we are putting YS, YS, then YSL1, YSL2 and then I have ER dummy. So, this is my specification and then I have robust and small. So, I am removing that no level equation so that why I am removing this? Because if I remove, that means I am considering the level equation also as a system of equation. Earlier I was considering only the differential equation, that is why no level, okay, that is why no level, okay, all right. And if we do so, then what is happening? My coefficient is going beyond 1. So, this is also problematic. That means, if we estimate a system GMM with capital and wedge also as endogenous along with the employment, then it is again going beyond the limit, we need to modify. So, what we will do, we will try to estimate the same system GMM with a different model specification and we will take N and then NL1, NL1 and then what we will do, we will take dot WK. So, 0 by 1 WK, L 0 by 1 dot WK means we are considering first order and second order lag of W and K, okay. But here we are considering only NL1, no second order lag, right. And then we have YR star and then within GMM, what we are doing? Within GMM, L dot, this is the precise way of writing the command, in, then W, and then K, and we are closing the bracket. This is my GMM, and what is my IV? My IV is YR star YR star, and then equation in level, and then I need robust and small. So, I have made a little change here. I have removed YS and I have considered only 1 period lag of employment, and then estimating the same system GMM, considering again in, W and K, all three are endogenous, unlike the previous case where in was considered to be endogenous. That means within the GMM it was only in L1, right. So, L dot in WK we are putting within the GMM. Then we are estimating the same model. Sorry, we are making a mistake here. We have to put YR star equation level, and then we need to put one more bracket. Okay. IV is YR star comma equation level, and then we need to put that. Then robust, small. And look at this, what is happening now. When I specify my model in this way, then I am getting the coefficient as 0.93, right, 0.93, which is lying well within the interval. So, that means what I am saying, whatever model you estimate, whether it is a system GMM or difference GMM, whether you consider only NL1 as endogenous variable, or you consider W, NL1 and KL1 also as endogenous, at the end of the day, my estimates should lie within the theoretically defined bound. And how do you get the bound? Your FE and OLS estimates, they set the upper and lower bound wherein your estimates from dynamic panel data model must lie, and if it doesn't, then we need to modify our model. How will you modify? That is up to you as a researcher. You need to contextualize you need to understand your problem properly. You need to read the theory to understand which variables should be considered as endogenous, which variable to be included in the model, all those things, right. And then if you see again the post estimation checkup, the Arellano and bond AR1 is rejected, but AR2 is not rejected, which indicates there is presence of first order autocorrelation, but there is no presence of second order autocorrelation. And again the over identification test, Sargent and Hansen, if you recall, yesterday we discussed that Sargent test as a test of over identifying restriction, they are undersized. The test statistic of Sargent test is undersized and extremely low power, with low power in a context when you are using too many instruments, and that is what is happening here. How many instruments? There are 113 instruments. So, Sargent test become weak when you have 113 instruments, right. And if that is the case, then what is the alternative? We said that we will go for Hansen test, which basically depends on that quadratic loss function or GMM criterion function, and then test statistic is constructed by getting that quadratic loss function and total number of observation n into q, and that follows again a chi-square distribution, and that works better in a context when you have too many instruments. And then if you go here, that Hansen test is satisfied. So, Sargent test is mostly what happens when it becomes weak, then what happens, it rejects the null in almost all the cases when you have too many instruments, and it never rejects the null almost all the cases when t is extremely large. So, that is why we are going by, generally we report the Hansen test of over identifying restriction after this post estimation checkup. Okay. And then as I said that these dynamic panel data model estimates are highly sensitive towards your model specification, and two types of specification basically we are talking about. Okay. Two types of specification, which variable you considered as endogenous. So, I will write it down clearly. The dynamic panel data model data model estimates are highly sensitive to number 1, treatment of variables as endogenous and exogenous. So, that means should we consider only n as endogenous variable, or wedge and capital also as endogenous? So, if your theory says no, W and K can also become endogenous while estimating employment, then we must include W and K also within the GMM style bracket, which specifies what should be your GMM style instruments and what should be your standard IV style instruments. So, right. So, specification of this GMM and IV alters your coefficients drastically. So, our dynamic panel data model estimates are sensitive to treatment of your variable itself, whether you consider a variable as exogenous or endogenous. Secondly, dynamic panel data model estimates are also sensitive to number of lags. Used to estimate. See, so far whatever dynamic panel data model we have estimated, we have not imposed any restriction on the number of lags. If you see here in the GMM type instruments, lag of ln, lw and lk, it starts from first and it goes up to 8th order, okay, up to 8th order, right. So, when you are using that many instruments, it may so happen that quality of the instruments goes down drastically. So, instead of 8th period lag, I can always impose restriction on how many lags to be used in my estimation.